Sodium and lithium are added to water. As you can see, sodium piece is moving much faster than the lithium piece. But besides explaining this using the reactivity series, what is the actual reason behind this? I'm sure that you're very familiar with this list, the reactivity series of metals that appear in any chemistry textbook. But do you actually know why the chemicals are arranged in this way? Have you tried to understand it? So why is sodium more reactive than lithium? It can't be just a fact. It can definitely be explained, and today I'm going to show you how. So for example, if I ask you, where does barium belong in this reactivity series? Although it's not here, however, we can definitely work it out where its correct position would be. And first of all, I have to explain why the metals are arranged this way in the reactivity series. Reactivity series meaning how reactive the metals are. And that means they have to undergo some sort of reaction. The metals, as they react, and in order to become stable, they need to form a full electron outer shell. Metals usually have 1, 2, or 3 extra electrons in their outer shell. They need to lose all of those in order to gain a full outer shell of electrons. And so metals form ions, positive ions. They need to remove electrons. And the ease of removing electrons depends on 3 major factors. The first one is something called shielding. The second one is the distance between the electron and the nucleus. The third one being the nuclear charge of the nucleus. So let me go through one by one. So shielding is the effective nuclear charge experienced by the outermost electrons is reduced because some parts of the nuclear attraction is absorbed, quote unquote, absorbed by the inner electrons, meaning the outer electrons experience less of the attraction from the nucleus. So this means that the more electron shells there is in an atom, the more shielding there is. That means that there's less attraction between the nucleus and the outermost electrons. Therefore, less energy is needed to remove the electron. So this is shielding. So the distance between the outermost electron and the nucleus increases down the group because you gain more and more electrons, and so the electron shells builds up and the outermost electrons get further and further away from the nucleus. And this means that because the distance is further away, meaning there will be less attraction experienced by the outermost electrons because it's further away, and it's less affected or attracted by the positive charge central in the nucleus. And nuclear charge increases as you move across a period and as you move down each period. So the more protons there are in the nucleus, the greater nuclear charge there is. And so therefore, as you move from left to right, top to bottom in the periodic table, nuclear charge increases, and this means that it is harder to remove electrons. Positive charge is stronger in the center of the atom, meaning electrons are more strongly attached, and therefore more energy is needed to remove electrons. So these 3 are the key factors that determine ease of removing electrons, which is central reaction of metals, because metals want to form need to form positive ions in order to react and become stable. But however, these 3 factors don't contribute equally to the outcome of the ease of removing electrons. So as you move down the group, the effect of shielding, the increasing distance, is greater than the effect of increasing nuclear charge. Meaning, as you move down a group, nuclear charge increases. However, because the elements below within a group would have gained an extra electron shell, meaning there will be more shielding experienced by the outermost electrons, and plus the distance increase between the nucleus and electrons, these 2 effects outweigh the effect of the increase in nuclear charge. Therefore, as you move down a group, it actually gets easier to remove electrons, and therefore the elements become, or the metals become, more reactive. And therefore, as you can see from this copy of the reactivity series, the first three, potassium, sodium, lithium, are group 1, and the next three are group 2. And potassium is at the bottommost of the group within these three elements, and sodium and lithium is at the top because of the effect of shielding and the effect of increased distance outweighing the effect of increase in nuclear charge. And the same applies for group 2. However, if you look again at the reactivity series, group 1 is above group 2, and the reason for this is because group 2s need to form +2 ions in order to gain a full outer shell to become stable. For group 1, they only need to remove 1 electron. And so this means that group 2 needs to overcome the energy to remove an electron twice as much as group 1 metals. And so therefore, of course, group 1 metals can react faster because they only need half of the energy needed to remove electrons compared to group 2 metals. And so, after explaining the reason of the order of elements within the reactivity series, let's return back to the initial question that I proposed, which is, where does barium have a place in the reactivity series? So, the answer is here, right between lithium and calcium. The reason is because barium is group 2. It needs to form a +2 ion in order to become stable, because after it loses 2 electrons, it will have a full outer shell. So therefore, it cannot have a greater reactivity than group 1s because they'll need to remove 1. However, within the group 2 metals, it is the most reactive because it is further down the group, meaning more shielding, greater distance between the outermost electrons and the nucleus, and these two effects outweigh the increased nuclear charge that barium has compared to the other group 2 metals shown here, which is calcium and magnesium. Within group 2, barium requires the least amount of energy to remove 2 electrons, therefore it is the most reactive within group 2. And so I hope this video has clarified your understanding of the reactivity series, and hopefully you don't see the reactivity series as just a list to memorize, but actually something that could be explained by thinking about how do these metals react, what does the role of electrons in this situation, which is the ease of losing electrons, and hopefully by thinking through it, you understand the reactivity series better.